Honors Algebra. This is Mr. Lawrence with your flipped lesson. I believe today is Thursday, May the 3rd, and excuse me, we are going to be solving rational equations now instead of just adding or subtracting, multiplying or dividing rational expressions. We might use some of the techniques that we've been using involving factoring, or we might use our LCD, but we'll use it for a different purpose. All right, now, I do have to apologize because I don't have the airliner with me, so I'm writing with a mouse pad, so my writing may not be the best. But let's say we have this equation, 6 over x minus 1 plus 2 equal to 12 over the quantity of x plus 1 times quantity of x minus 1. One way to approach this problem is to get the LCD. All right, we're going to look for the LCD. Now, normally I would have had to factor the denominator under the 12, but I gave you the factored form in the interest of time. I know my LCD is going to involve a quantity of x plus 1 and a quantity of x minus 1, right? Okay, so there is my LCD. Now, I might make a little mental note here that I know that is the same as x squared minus 1. And you'll see why I made that little mental note. Okay? Now, this first fraction here, the 6 over x minus 1, I'm not going to try to get a common denominator. Instead, what I'm going to do is I'm going to get rid of my fractions. So I'm going to take x plus 1 and x minus 1, and I'm going to multiply all three fractions by this. I'm going to multiply there, I'm going to multiply here, and I'm also going to multiply this 2 by x minus 1, x plus 1. Why am I doing that? Okay, why am I doing that? I spread my stuff out a little bit more. Well, I know that if I multiply through by the least common denominator, all my denominators will disappear and I won't have any fractions anymore. This x plus 1 and that x plus 1 will cancel. This x minus 1 will cancel with that x minus 1. This x minus 1 will cancel with that x minus 1. And there's no fractions involved. So now, when I look at this first fraction, what I have is 6 times the quantity of x plus 1, which is 6x plus 6. All right, this x plus 1 quantity times x1 minus 1 quantity times 2, well, I know that the two quantities FOIL turns into x squared minus 1. So I know that if I multiply that by a 2, I will get plus a 2x squared minus a 2. And the right-hand side becomes simple. It turns into simply a 12. Okay, I'll simplify my left-hand side. I'll get 2x squared plus 6x, and then plus 4. That'll equal 12. And I know that this is a quadratic equation. How do I know that? Because the highest power is 2. All right, so this is quadratic. To solve it, I want it to equal 0. So I'll subtract 12 from each side, and I'll end up with this equation. 2x, hold on, I can't see what I'm doing. 2x squared plus 6x. When I subtract from 12 from each side, I get minus 8. And that'll equal 0. Now, I know that that can be factored. I'll pull out a GCF. I could go right to the quadratic formula, but I think this one factors. So I'll pull out a GCF of 2, leaving me with x squared plus 3x, and then minus 4, and that is equal 0. And then I can see that that will factor 2 times the quantity of x plus 4 times the quantity of x minus 1. And that will equal 0. And now I can say that x must equal 4 or 1. Oops, negative 4. X must equal negative 4 or 1. Those are my two possible answers. Now it looks like I'm done, except I noticed that back in the original problem, that if I put 1 in this quantity right here, if I put 1 in there, I get a 0 in my denominator, and that's a major no-no. Same thing over here. If I put 1 in for x, I get a 0 in my denominator. So I know that this solution will not work. So my only solution for this is x equal to negative 4. You can test it. You can do 6 over negative 4 minus 1 is negative 5. What am I doing? I'm substituting it back into the original equation. All right, plus 2, which this is negative 1 and 1/5, right? Plus 2 will be 4/5. Now the right-hand side is 12 over x is going to be negative 4. So this quantity here turns into negative 3. That quantity there is negative 5, so that turns into 15. If I simplify 12/15, dividing both the numerator and denominator by 3, I end up with 12 divided by 3 is 4, 15 divided by 3 is 5, and sure enough, it works. There you go. All right, let's look at one more example here. This one I'm going to do differently. I could multiply through by the LCD, but I'm not going to. Instead, on this one, remember a couple days ago somebody asked me, when do you cross multiply? I have a fraction equal to another fraction, and there are variables. Now it's time to cross multiply. I'm going to do 5 times the quantity of x squared plus 2. Close my quantity. And then I'm going to multiply the other way. And I'm going to get a FOIL problem of x plus 3. Yikes, this finger mouse is difficult. Times quantity of x plus 1. All right, so when I distribute on the left-hand side, I end up with 5. Oh, I don't want it over there. Let me put it over here. 5x squared plus 10, and that will need to equal what I get when I FOIL the quantity of x plus 3 times the quantity of x plus 1. That'll be an x squared plus 4x plus 3. Okay, now I know that if I subtract off the x squared, so get all the x squareds on the left-hand side, I'm going to end up with 4x squared. I'm going to subtract this guy off from both sides. So I'll get a negative 4x, and I'll subtract a 3, and I'll get a positive 7, and it equals 0. Why do I want it to equal 0? Because it's quadratic. If it was linear, I get all my variables on one side, all my non-variables on the other, and then I would solve for x, listening to Saddam. But with a quadratic, I want it to equal 0, so I can either factor or do the quadratic formula. I don't think that this is going to factor, so I'm going to go to the quadratic formula. So A is going to equal 4. B is going to equal -4. And then C is going to equal 7. Right? I'm going to check my discriminant really quick, and I know I'm going to get 16 for the b squared part minus 4 times 4 times 7, right? And that is going to give me a number less than 0, because 4 times 4 is 16. When I multiply that by 7, I get a number much larger than 16. And I'm doing 16 minus whatever this product is. So my answer will be less than 0. I know right off the bat that there are no real solutions to this problem. Okay? All right, tomorrow in class you'll get some practice with these. Should be pretty simple. All right, there we go. So I'm going to go ahead and end the video now. Mr. Lawrence signing off. Good night, everybody.